Now, so we're back to the notes and we're on page 34 of the notes, and we're going to look at a topic that's going to lead us to the maximum and the minimum points of quadratic graphs. Before we can really talk about how to find the max and the min, we need to learn a new technique, which is completing the square of a quadratic trinomial or quadratic equation, if you like. And basically, what this is about is we're going to write our quadratic equation in the form x plus something squared plus something else equal to 0. I'm using h and k here. I could use a and b as well. So x plus something, and square it, plus something else equal to 0. So for example, I might have x plus 3 squared plus 4 equal to 0. Okay? Why do we do this? Why? Well, you remember that when we looked at lines, for example, we had two different ways of writing lines. So like we could write a line as 3x plus 2y minus 7 equals 0. Okay, we could write our line like that. Or we could write exactly the same line as y equals minus 3 over 2x plus 7. And why did we have two different ways of writing it? Well, this one's maybe the more straightforward way. We've got all our whole numbers, everything's on one side equal to 0. But this way, it tells us the slope and it tells us the y-intercept. So when we write our quadratic like this, it tells us certain information about it. It's going to tell us where the maximum or the minimum of the quadratic is. Okay, so that's why. So we do it to find the max and min point of the quadratic. We'll show that on graphs afterwards. First of all, though, we need to learn how to do it. So that's the why, and we'll come back to using the why after we learn how to do it. Now you'll notice down here, this is slightly different. There's a number in front of the brackets here, and that's because not every quadratic equation starts with just x squared. Some quadratic equations might have a number in front of that. So whatever that number is would go outside the brackets. But for the moment, just for the first ones we're doing, so for the first examples, there will be no number, no x squared coefficient. So no number in front of the x squared. And later we'll come back and we'll look at what happens when there is a number in front of the x squared. It's actually very easy to deal with, but it's easier to get used to this sort of equation first. So go on to page 35 of your notes and we'll look at example 1, and we want to complete the square. So that's how we write it. We say complete the square. So this means write it in the form x plus something all squared plus something else. I want to write it in that format. Now, back on page 34, there are some steps, but I'm not going to use them yet. They're a shortcut, and I want to show you the long way first, and then we'll come back to those steps, and you can decide yourselves whether you'd like to do it the long way or the short way. So the way we're going to do it is we'll put our quadratic equal to x plus h all squared plus k. And the second thing we'll do is we will multiply out our brackets and then that's actually going to tell us the answer straight away. Finally, we can equate the coefficients to find h and k. So let me show you what I mean by this. So we start by saying that x squared plus 6x plus 10 is equal to x plus something all squared plus something else. Okay? Well, I'm going to square out the brackets on this side, and I get x squared plus 2hx plus h squared plus k. Where did I get that from? Pascal's triangle, if you like, or square the first, square the last, double the product. And then, so this is x squared plus 6x plus 10. And then I'm going to say my x squared coefficient, it must be the same on both sides. My x coefficient must be the same on both sides. And my constant term, the thing with no x in it. So there's no x here, so this is my constant on this side, and there's no x here, so this is my constant on this side. Now this looks quite long for the first one that we're doing, but it gets quite quickly. The x squareds, well, that's trivial. X squared equals x squared, so we can kind of ignore that at the moment. Let's look at the x terms. So my x term on this side is 6. And my x term on this side, my x coefficient on this side is 2h. 6x is equal to 2hx. I'll put in the x's, but we can kind of ignore the x's. So the coefficient on this side, the 6 on this side, must be equal to the 2h on this side. And I can divide across by 2, and h is equal to 3. Okay, so going over that again, the 6x on this side must be equal to the 2hx on this side. I can ignore the x's, so the 6 is equal to 2h, and then I'm just solving that, dividing by 2, so h is equal to 3. Now I know a value for h, and I'll do my constant term. So my constant term, I have 10 on this side, must be equal to h squared plus k. But I know the value of h. I know that h is equal to 3. And it's just a little bit neater maybe to write it the other way around. So h squared plus k is equal to 10. I'm just writing it the other way around there. So k is equal to 10 minus 9, which is 1. K is equal to 1. It's a little bit long the first time I'm doing it. I won't spell everything out quite as much when I do the further examples. Am I finished? Well, let's come back to what I was asked to do. I was asked to write this quadratic in the form x plus h all squared plus k. So the final thing I need to do is say that x squared plus 6x plus 10 is equal to x plus h, x plus 3 squared plus k plus 1. And that's my answer. This part here is my answer. It took a little bit of time to get to that. I'm going to go a little bit more quickly to show you how quickly we can do it. So you don't need to write down all these steps. This is an explanation for our notes. Okay, let's go a little bit more quickly now with this one. X squared plus 10x plus 37 is going to be equal to x plus h squared plus k. That's what I'm being asked to do when they ask me to complete the square. I square out my brackets. X squared plus 10x plus 37 is equal to, and you'll start to notice it always squares out the same way, x squared plus 2hx plus h squared plus k. Then I must equate my constants will be equal to each other and my x terms will be equal to each other. Of course, the x squared terms will be equal to each other too, but I don't need that right now because there's no number in front of the x squared. So my x terms give me, and I'm just going to write it this way around, 2h is equal to 10. And that means that h is equal to 5. my constant terms, same thing, I'm just going to write it this way around. H squared plus k is equal to 37. But I know the value of h, that's 5. So 5 squared plus k is 37, which means that k is 37 minus 25, and k is 12. And so for the final step, I write down this: x squared plus 10x plus 37 is equal to x plus h, x plus 5, 5 is coming from the answer we got there, plus k plus 12. So this is called completed square format. That's my completed square. Okay, let's do one more, and then I am going to ask you to try just a few yourselves for homework tonight. If you want to pause the video and try this yourselves before you see my answer, just to check if you can do it, that's fine as well. So again, x squared plus 2x plus 5 must be equal to x plus h squared plus k. And then I square out the brackets. X squared plus 2hx plus h squared plus k. Highlight my x terms and highlight my constant terms so I know what I'm equating. My x terms on this side are equal to my x terms on this side. So twice h, 2h is equal to 2, which means h is equal to 1. Now, if you were to go back and look on page 34 at the shortcut, the first thing it says is have the coefficient of x. Divide the x coefficient by 2. And you can see that's what we've been doing all along. So you can learn a shortcut with these as well. I want to show you where it's coming from before we take any shortcuts. Those are the x terms, and then my constant terms. On this side, h squared plus k is equal to, on the other side, 5. So we know the value of h, so we can say that k is equal to 5 minus 1, k is equal to 4. And finally, we write down our answer: x squared plus 2x plus 5 is equal to x plus h squared plus k. And that is our completed square answer. Let's look back at the shortcut again, just before we stop for today. Have the coefficient of x, square this value and subtract it. So square this value, if we look at this one, 25, and subtract it from that. So I have this, I get 5, I square it, I get 25, I subtract it from this, I get 12. So there is a shortcut, and that will always work out so long as there's no number in front of the x squared. Now, so those 3 examples, do work through those at your own pace and make sure you understand them. Here's the steps that I'm going to use. We're going to set it equal to x plus h all squared plus k, because that's what complete the square means. Multiply out the brackets, put the x terms equal to each other, put the constant terms equal to each other, and find your 2 values. Okay, thank you. Let me know if you have any questions.